Hello, in this lesson, we are going to explore the differences between specific types of sequences, and then we're going to look at a couple examples of all of those. When I say number sequence, or when I say sequence, all I'm referring to is a list of numbers. That's all that really means. And then those lists of numbers may have specific attributes that make them have a pattern. And then we can use inductive reasoning, which we talked about in our last video, to draw conclusions based on that pattern. So two sequences that you're going to see a lot in mathematics are arithmetic, looks like arithmetic, but pronounced arithmetic, and geometric. So arithmetic is a sequence of a number sequence based on addition. And then geometric, well, let me refine that. Not just any addition, but addition of the same number over and over. So we call that a common difference, which is down here, common difference. But I'll say on addition of a common number. That's called a common difference. That number that's being added each time is common difference, and that refers to arithmetic. So long story short, arithmetic is associated with adding. Geometric sequences are, or a geometric sequence is a number sequence based, whoops, I spelled that wrong, sequence based on multiplication of a common number. So again, in both of these, it can't just be any addition, like adding 2, adding 3, adding 4. It has to be adding the same exact number every time. Same for geometric. It has to be multiplication of the same exact number every time. Now, geometric may disguise itself as division in your mind, but technically division is multiplication of fractions. So even in the case where it looks like division, where it's decreasing each time, they're actually multiplying by a fraction instead. So just kind of keep that at the front of your mind. So a common difference refers to an arithmetic sequence, and a common ratio, whoops, refers to a geometric sequence. And ratio is referring to that common number, and I mentioned that that number could be a fraction, which could also be referred to as a ratio, a ratio. So we have a couple examples down here. We are deciding whether it's arithmetic or geometric or neither, and then finding the next term in the sequence. So in the first example, arithmetic is usually pretty easy to identify because it's just adding, and adding is pretty simple. You can see here, we're just adding 5 each time. And we can say the next number is 25. And that was based on an arithmetic sequence. Now pause the video, try the next two, and come back. The second example here, part B, is a geometric sequence because we are multiplying by 4 each time. 2 times 4 is 8, 8 times 4 is 32, 32, and so on. So your last step is 128 times 4, which is 512. And then the last example here, you might have tried a couple things, and I'm trying to show here my trial and error. First, I was thinking, oh, we're multiplying by 4, but 4 times 4 is 16, which is not the next number. So that's not it. And then I thought, well, maybe we're adding 3. 4 plus 3 is 7, not 9. So that's not it, which means that it is neither geometric or arithmetic. It is a sequence, but it is not those two. So this would be neither. And we could find the pattern and state the next number, 1 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, which means that the next number is 6 squared. So that's how you would do that. I didn't have one in here, but I do want to show you an example of geometric where the common ratio is a fraction. So let me go up here, just make an extra example. Let's see. Let me do 32, 16, 8, 4, and it goes on. So you can see that the numbers are getting smaller. And since it's getting smaller, you could look at it as division. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4, and so on. And that would get you the next number in the sequence. But technically what's happening is we're taking these numbers and multiplying by a half. So dividing by 2 is the same as multiplying by a half. So just be careful of that as you work on examples, to use a fraction instead of saying division. So our next number would be 2. And this is a geometric sequence. The next type of sequence we're going to look at is we're going to have to use a method. It's called the method of successive differences. And what that means is there may not be a pattern in the first, like a common ratio or a common difference in the first line. But if you go one line further, there could be a common difference there. So we can use the method of successive differences to find that. And basically that kind of leads into like figuring out what type of function you're dealing with. So for example, if your common difference is in the first line, that's a linear function. If you have to go one more step, that's a quadratic function. If you have to go a third step, that's a cubic function, and so on. So that kind of goes into algebra a little bit. You don't have to necessarily know that for this course, but I'm just trying to let you know where it's leading. So a method of successive differences is a method for finding that common difference further down the line, basically. So I kind of summarize what I said there. On the left of this, on the right in pink, I'm going to show you an example. Now in the example, I'm kind of reverse engineering it to get to an example that works. Basically, you could kind of trial and error it until you get there, but I thought if I just work my way backwards, maybe that would be easier. That's just a problem solving technique, which we'll actually talk about in a later video. So in the bottom row in pink, I started with a number. It doesn't matter. You could pick 2, 4, you could pick any number. I just picked 3 because I like 3. So I'm going to use 3 as that common difference in the second step. So this is like, I've done the method of successive differences and I've ended up with 3 as my final answer. So I'm working backwards. And then I picked, in the next step, I picked 2 numbers that have a common difference of 3. So keep with me. So if 8 and 11, I just picked 2 numbers. You can pick any 2 numbers that have a common difference of 3 or 2 or 4, or whatever number you picked. And then since I picked those 2, that's going to decide my next numbers. My next number is going to be 14, 17, and 20. Then for this last step, I'm going to draw my little triangles again that point to my differences. Those are my little branches. And in the first step, I'm trying to find 2 numbers that have a difference of 8. I'm going to use 10. Sorry about that. 10 and 18. Now those 2 I picked, but the next numbers in the sequence are going to be based on those 2. So you can kind of see I've followed this pattern. 18 plus 11 gives 29. 29 plus 14 gives 43. 43 plus 17 gives 60. And this is going to give me the last number in my sequence, which is going to be 80. So this is not necessarily a process that you have to go through, but this was the process I had to go through to come up with an example. So in the next couple examples, you're going to be given the numbers and you're going to be finding that common difference down here. I just kind of wanted to show you the engineering behind that. And so you'll be given these numbers and you'll be using the method of successive differences to find the pink numbers down here. But that's kind of how it all ties together. We're using addition to find those next numbers. So down here, I promise this is going to be a little bit easier than what we just did in the example above. So I want you to practice now knowing the full picture. I want you to practice on these two examples. Pause the video, practice, and come back. For part A, you're finding the difference between these numbers. So we go up 8, up 10, up 12, and then right here, I left a blank because I wasn't sure what was next. And since there's not a common difference yet, we're going to go one more step. So up 2, up 2, up 2. All right, so now we have a common difference. And now we know that it's 2. That gave me this blank, 14, which gives me this blank, 58. So now I'm going to show you walking through that in case you didn't catch it in this next example. So I'm going up 10, up 22, 40. Let's see. Pull this out so I don't have to think too hard. 142 minus 78, 64. Now, I don't know what's next because I'm not seeing a common difference, which means I have to go another line. That's 12, 18, 24. Again, I don't know what's next, so I have to go another line. Let me put a blank here before I forget. I'm going to change colors again. 6, 6. Okay, so now we have a common difference, which means I'm going to start finding those common different or those missing pieces. So I'm going to work my way from the bottom up, which means to go up 6 one more time, that's going to give me 30 for the next step, which means 64 plus 30 is 94 for the next step, which means for the last step, I'm doing 142. Uh-oh, I'm pressing all kinds of buttons. 142 plus 94, 236 for our actual answer. So it is a little bit tedious, which means that I would recommend for problems like this, staying very organized. You don't want to create a mess all over your paper. You want to try to do similar to what I've done, if not better than what I've done, where everything's lined up so that as you work from your the bottom back up to the top, like I did in the orange step there, I can easily see it's all lining up to figure out the correct missing spot. So just be very careful. That goes that's good advice for all of mathematics. Anytime you're doing mathematics, it's a great idea to be organized, very neat, very meticulous. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. See you in the next one.